Okay, so we are saying, having attended previous courses about cloud computing, we now have a good understanding of virtual machines and the resources they use. We know what a virtual machine is, and also we know the resources they use, which we virtualize. So this chapter, we are going to focus on when and where we would need to use virtual machines and what virtualization features do the virtual machines provide. Okay, so we have our objectives, and we are saying that upon completion of this course, you will understand virtualization features. You will also understand where and when these features may be used. So quick question, what are the benefits of using virtualization? Basing on what we have covered before, can I get someone to tell me what they think could be some of the advantages or benefits of leveraging or using virtualization?
Helps in maximum utilization of hardware resources.
This is Andrew.
To me also, virtualization is cost effective.
Okay, cost effectiveness.
Mic check.
Yes, Stephanie.
Virtualization improves the reliability of workloads running on virtual machines.
Okay. That is really good. That is really good, and that is true. We have already looked in the previous chapter, and we said that those are some of the things that our virtualization can do, and we understand that cloud computing is a service delivery model, like some of our friends stress. It was confusing them when they are saying it's a technology. So, and virtualization is a technology, okay? So cloud computing is a service model, while virtualization is the underlying technology. It's a technology. And we went ahead and understood that virtualization is the main technology in the era of cloud computing 1.0, isn't it? So now, what kind of features that this virtualization provide for us? How can we be able to utilize these virtual machines, or how can we benefit from the whole technology of virtualizing hardware resources so that how can we benefit from them ideally? So we looked at that some of the characteristics of virtualization or the advantages of virtualization. We said we have 4 of them. Who can mention one of those 4 characteristics of virtualization? Come again?
Good network.
Isolation.
Isolation, partitioning, yes.
Encapsulation.
Partition, isolation.
Standalone or independent.
Standalone or independent. And encapsulation. Okay, these are some of the characteristics that we have with our virtual machines or virtualization. So now we want to look at the features or characteristics. Oh, we are even here. Looked at them. Who can remind us what we talked about during our partitioning? What happens here? What is this characteristic of virtualization?
Check.
Yes, please.
Partitioning is just basically the physical machine, which is the host, can be partitioned into smaller, all other independent machines, which we call the virtual machines.
Okay.
So out of the one host machine, you can get two or more virtual machines out of it. Can partition it into.
Yes, you can partition our hardware resources of this machine, and we can have different partition where we can create different machines and they're using these partitions. What about pairs? How about isolated or isolation?
Isolation basically means that these these VMs that we've created, or these partitions that we've created from our physical resources, can stand in isolation of each other. So therefore, if they can work independently, and if anything happens to one of them, whatever happens to one of them cannot affect the other partition that we've created or the other VM that we've created. So things like maybe crashes or viruses affecting one, they cannot, does not mean that they will affect the other partitions as well.
Okay. How about Helena? Yes, please.
The whole aspect of isolation also, I remember you talked about them being stored in logical folders. So the aspect of them being logically separated, I think also contributes to the isolation bit. So whatever happens to one cannot affect others.
Okay, then Helen, can you also tell us about encapsulated and independent? Helen, I saw your hand up. Okay.
Hello?
Yes, Helen.
Mic check.
We can hear you. Go ahead and speak.
About the independent feature, we said that these VMs are not dependent on the host machine. Like they don't need to know the underlying hardware. As long as the hypervisor has the access to the file extensions, that's all.
Okay. Can I have Stella telling us about encapsulation?
Yes, about encapsulation, we said that the virtual machines are converted into a logical file with the user data in it. So these files can easily be moved or transferred from one virtual machine or one host to another.
Okay. So yes, please.
Encapsulation also, I think there is the aspect of the files being created while creating the VMs are have sort of an abstraction layer, and they cannot easily be understood actually by, say, any other file system apart from the hypervisor. Say viruses cannot attack them, and yeah, something of the sort. So they have an abstraction layer that encapsulates them.
Okay. So let us look also at the next bit. So we want to introduce ourselves. Helen, could you please mute? Okay, thank you. So let us look at the introduction to clusters. Okay, and we said, what is a cluster? In the previous class, we were mentioning a cluster. So what is a cluster?
A combination of different
Combination of files.
Files?
Combination of CNAs.
Yes, combination of CNAs, or you can actually call them hosts or physical servers or physical machines, isn't it? This guy, when you combine them together, we come up with our cluster. So in actual sense, a cluster is a group of computers that collectively provide resources for users. Okay? So if we are looking at them and we are getting our resources from here, if we are getting storage resources from here, what kind of storage virtualization would that be?
distributed.
Yes, distributed. We said distributed, we are getting them from different machines or different hosts connected on our network, while centralized, we are getting them from our disk enclosure, which is centralized. Okay, so we are saying here that these CNAs, the computer node agents you're seeing, they are providing resources for the users. Which resources are they providing? You can mention them briefly, quickly.
Memory.
We have memory, which is part
CPU.
of compute. And in the compute, we have already mentioned the things that are inside there: CPU memory and input and output operations, isn't it? Then which other resources?
Yes.
Storage.
Storage. What else?
Network.
Network
Network.
resources. And for us to have something called a cluster, we should be able to get all these resources provided by this machine. So a complete cluster must contain all those types of resources, and they are put together. So let us look at one of the future of a cluster. We are now looking at the features of a cluster, and we are saying a cluster is a group of different hosts put together. So one of the feature of a cluster, and we have been looking at it or mentioning it before, is what we are calling high availability. Okay, so with high availability, a virtualization cluster usually they use shared resources, and these virtual machines consist of configuration files and disks files. Which disk file we have already looked, they can be encapsulated and they can be isolated, and they're also independent of the hardware or the underlying hardware infrastructure. So this means that during our high availability, if one machine fails this machine, we can just get our configuration file and storage files and all the user files and remigrate our virtual machine from this CNA to our other CNA, and even the end user will not notice, and we shall continue operating and our clients are happy. So what high availability helps us with, we are able to detect the host faults, that there is something wrong with one of our hosts, therefore our virtual machine should be migrated to this given host. Or maybe if we are having failures for our virtual machine is failing to start up, we are also we use high availability to help us determine why isn't our virtual machine loading, or why isn't our virtual machine starting up. So if a compute node belongs to a faulty CNA, or one of our node, our host becomes faulty, then our virtual management, or in the case of Huawei, we use a VRM, it rebuilds the faulty virtual machine on other nodes. It rebuilds it on other nodes, and that means that our machine is going to be highly available to all the people who are going to use it. Okay, so here, as you can see, let me clear my screen and I play this animation. So if one computer becomes faulty here, we are going to get our two virtual machines which have been inside this node, and after getting our virtual machines that are inside that node, then we are going to migrate them evenly depending on the rows we set, and they're going to be evenly distributed on other available hosts in a cluster. Could someone please mute? Gideon, could you please mute?
Yes.
Thank you. And they're going to be migrated to other hosts available, and this is what we are calling high availability. Okay, this is what we are calling high availability. So to check whether a compute node is faulty, the administrator needs to periodically establish communication with all nodes. That's why they must be connected to each other. He must establish communication to all nodes, and that is done periodically. So if the communication with a node fails, the node may be faulty. So this prompts the administrator to now know that, you know what, this node may be faulty, therefore we should migrate or replicate our other virtual machines on our the available hosts, so that the end user, whoever is accessing these virtual machines, doesn't even get to know that one of our hosts in our cluster where our virtual machine was residing is faulty. And then you're able to fix it, put it back, and then they will be migrated back to it. And this is the beauty, or these are some of the benefits of virtualization. So when we are using Huawei Fusion Compute as an example, they use what they are calling a heartbeat. They're using what they are calling a heartbeat mechanism. Okay, they're using what they are calling a heartbeat mechanism, and this heartbeat mechanism is usually used to process, is usually used to run, or it is run inside a process or a service on one of these guys. Okay, so the host then will send this heartbeat mechanism between our CNA host and a virtual resource monitor. Okay, and our virtual resource monitor, it will send them between, and this virtual resource monitor enables the this virtual resource monitor will now be able to check whether our CNA is faulty. If it doesn't receive the heartbeat within 30 seconds, it doesn't receive the heartbeat mechanism within 30 seconds, then that means for 10 consecutive times, the first time it does not receive, the second time does not receive, the third time does not receive, then it will assume that our host is faulty. So if the VRM service on a network is abnormal, or maybe timeout may occur, the timeout log is printed within the 13 seconds stamp. Okay, so the timeout dead interval is usually 3 seconds, then plus the socket timeout, which is 10 seconds. So which totals up to 13 seconds. Keynote to take that our heartbeat is set within intervals of 30 seconds. Every after 30 seconds, they send a heartbeat mechanism to check and detect to see if our host is faulty. So if it does not reach any of these guys for 10 times, then we shall determine that maybe our host is faulty. So after receiving the heartbeat message from our host, our virtual resource monitor sets the heartbeat frequency variable to 10. The default value is 10, which can be changed by modifying the configuration files. Okay, so this is what we are calling high availability. So usually high availability is used together with application layer high availability to improve the service recovery, success rate, and efficiency. So what happens is that usually high availability is always needed or is worked upon in the service plane. So if an active virtual machine is faulty or it cannot be restored, services will be recovered on the standby virtual machine using high availability technologies. Some of them, we have what they are calling a floating IP. We're not getting into that, and also keep alive. Okay, so that is high availability, but what you should take out from this feature is that if one host becomes faulty, then our virtual machines can be migrated, just like you saw, can be migrated from it to our other sites. Okay, they can be migrated from it to our other hosts that are available. Okay, like you see here, our host becomes faulty. When our host becomes faulty, then our virtual machines you're seeing, they go, and this is what you're calling high availability. So let us also go ahead and look at load balancing. Like you hear the word, you have some kind of load which you have to balance. So virtualization helps us, or we benefit from virtualization because we get an option to balance our load inside our cluster. So load balancing is a cluster technology that distributes the load. You see this virtual machine here. Are you seeing it, all of you? Are we on the call?
Yes.
Yes.
Yeah.
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 Yes, we are.
Please kindly, if you have issues with being part of the class, kindly just send me an email, because we use that as evidence that you are part of my class.
Yes.
That way I can easily take note of the people who have had issues. Of course, you can also leave something here so that I'll be able to know that you are actually part of it. So, are you seeing this guy here? We are overloading him, isn't it?
Yes.
We see we have created 4 virtual machines on it, and we are seeing we have one CNA, or our host, and it has only one virtual machine, isn't it? So basically, with the load balancing, you're just trying to distribute the different loads to other hosts that are available. So such as network services and traffic, usually. So to multiple devices such as network and firewalls or links. This improves service processing capabilities and it ensures service reliability, so that one guy does not, or one guy is not overwhelmed with the load. Because what happens if you are giving this one person the load, then the person accessing this virtual machine and this virtual machine, remember they are competing for the same resources on this host, and then it will be overloaded because they're all getting their resources, their CPU, their memory from this one person, and then at the end of the day, you will have poor performance, which we don't want. And with virtualization, we are leveraging on that opportunity. And as you can see in the animation, this machine is not happy. It has its sad face because it's being overloaded. And then we use our cluster feature of load balancing to balance the load. We realize this person has one virtual machine accessing or utilizing the resources, and this person also had one virtual machine. So let us distribute this load which we have here to them so that we can evenly balance the load across our cluster. And now you see the person is happy. So the advantages of load balancing is that this brings about high performance because we are evenly distributing the loads to multiple devices, thus improving the performance of the entire system. We also can scale. It gives us the opportunity to scale our resources or scalability. Load balancing easily increases the number of devices or links in a cluster to meet the service growth. In that, if we have our, if all our machines are not happy and they are in red, they are complaining, we can just add one host here with other resources, or even add another one here, and we connect it to our switches, and then they get one virtual machine from that guy, and then one virtual machine from that guy. Okay, so we are able to balance the load, but here we have also scaled out or scaled in depending on the need of our infrastructure. So that is load balancing, and also because it has the ability to evenly distribute the load, that means that services are highly reliable. You're not having one virtual machine which is overwhelmed, that whenever you're trying to access it, you get errors. So if one or more devices, all the links are faulty, services are not interrupted. This improves service reliability, because remember, all these features work together. Because you have a high availability and load balancing, and this guy is faulty, we use high availability, and we also, as we are doing our high availability, we also implement our load balancing, and we evenly distribute our virtual machines so that they can be able to access resources from different hosts that are available on our network. And it is also easy to manage, because management, when you are concentrated on the devices that use the load balancing technology, the device group or link group only needs to be configured and maintained. You just put in your configuration that if one machine here gets to 75% of usage, and we have one that has 25, please migrate this one and migrate that one, so that, or actually configure this virtual machine to access other resources from one which has low usage. Okay, so that is load balancing for you. Okay, so this is what we are calling load balancing. So in a virtualized environment, load balancing is generally implemented on compute nodes based on CPU and memory usage. Please take note. We usually focus our load balancing.
Increases.
Wanyana Ruth, you have echoes. Are you using two computers? Okay, so we are focusing on two. We are focusing on two kinds of. They are based on the CPU. Load balancing is also based on the memory usage. Please take note of that. So during virtual machine creation and running, the management system detects that the usage of all physical resources in a cluster use the intelligence scheduling algorithm, to determine the optimal host for running virtual machines and migrate the virtual machines to the optimal host which is available, which has resources available to it. So by means of live migration. So with load balancing, we can support live migration. Someone is using the virtual machine already, but we are able to migrate it from actually using these resources to another host on the cluster, thereby improving global service experience. Okay, so but usually a large number of virtual machines are running on the host or on the third host. A period of time, the system automatically detects the load, like you saw here, automatically detects that the load on the third host is heavy, and then it migrates this load of virtual machine on the other light load hosts, the ones which are having a few one. So you can also take note that the load threshold can be specified by the system administrator. Okay. So the threshold can be specified by the system, can be manually specified by the system admin, or it can be defined by the system. So in Huawei Fusion Compute, if CPU and memory usage of a host exceeds 60%, okay, then our virtual resource monitor will migrate virtual machines on that host to other virtual machines. So in Fusion Compute, if we get 60%, it will migrate them to other hosts. So before the migration, the administrator can send an automatic migration task. Alternatively, the administrator can also manually perform the migration after receiving a notification. So if you're on your dashboard as an administrator and you receive a notification that you have used 75% of your resources on this host, then you can go ahead, punch in, go click, and then you migrate one of the virtual machine with our live migration from this to that. Okay. So that is what we are calling live migration. So let us also look at another feature called scalability. When you hear the word scalability, like we are able to scale in and either able to scale out. We are able to expand, isn't it? All. What is the opposite of expand?
Minimize.
Contract.
A contract or minimize or whatever you can say. So usually in traditional and virtualized environments, all services that are deployed on a physical machine. Do you know what this means? If you have your computer here and you realize that the hard disk you bought, or if you have your server and clients are accessing your services from your computer and you realize that the hard disk you bought is full, tell me, how can you increase these storage resources? Can someone tell me how?
Since Samuel is off, I think Paul and one can take over.
Okay.
Who wants to take over?
Mic check, I have a question. Is it scaling inwards and outwards or scaling upwards and downwards? What is the difference?
In and out.
Okay, so I was asking a
Either
question. If we have our physical machine and realize that we are out of storage and we need to increase our storage, or the RAM is not enough, how can we increase these resources on our physical machine without virtualization?
Yes, and mic check.
Yeah, yes, please
mic
go
check.
ahead.
By adding RAM or by adding multiple machines.
Without virtualization, how are you going to add another laptop on top of your laptop?
Without virtualization,
Yes, Umar.
If they're on the same network, are we assuming they're on the same network?
We are assuming this is your physical machine. You have not virtualized any kinds of resources. How are you going to be able to increase on your storage? And you have your application running on your hard drive. It is running live. How are you going to be able to increase on your storage?
Mic check.
Yes, please.
Mic check.
Yes, tell me.
You will have to shut down the machine, open the system unit, and put new RAM chips, and maybe mount another hard disk.
Yes. So, but that means that all the services have to be temporarily shut down.
Yes.
Mic check.
Yes, Joshua.
Mic check.
Yes, Joshua.
You can do hot swapping.
Hot swapping, you can do
by like
RAM.
You're saying about RAM or storage?
Your memory resources. Okay, let's talk about hot swapping. You have your hard disk and it is full, which has your operating system. Are you going to hot swap it?
Okay, you only like hot swap the drive which has the data, not the operating system.
Okay, so if you have a service running, here, already your program installed. So hot swapping means you're going to remove this disk where you have your service installed and you put another disk. Won't you have an interruption on your service?
Exactly, you'll have.
You have. So one of the benefits of virtualization is that we can actually be able to use the scalability feature so that we can either increase on our resources or decrease them as we need to do, as accordingly, okay? So if we have and we want to expand our memory, let's say from about 200, or let's say from about 512 GB to 1 terabyte, okay? To 1 terabyte. This kind of scaling mode is called vertical scaling, or sometimes we are calling it scaling up, okay? Because we are increasing on something. However, the hardware resources supported by a physical machine have an upper limit. Even if you if you're using a physical machine and remove our hard drive and we put it there, using our vertical scaling mechanism, and we add there other resources. If you need to use, like, let's say about 800 TBs, it is hard or rare to get just one physical machine that is going to give you the capability of using all this resource in one machine without you needing to use a storage server, which is also virtualized in a way so that you're able to access those resources. So this means that as we keep on increasing or adding their things and replacing machines, okay, we have some kind of migration and maintenance, and we are slowing down in a way. That's why we are introducing this feature of scaling, so that we are able, when the service or when we having our service, we only need to add resources to our resource pool without necessarily having to add hardware themselves. We just need to get our host, add it there, and then we are good to go. So the actual implementation, all we need is to add servers. So this means, or this is called horizontal scaling or scaling out, okay? The difference is here, with vertical scaling, or what we are calling scaling up, is that we are just adding hardware resources inside our physical server. But we are also looking at another mode of scaling, which we are calling our horizontal scaling or scale out. And here we are saying we don't need to cover hard disk. We just get our server, which has all the resources. We increase them at once and add it there. Isn't it? So clusters in this or in virtualization, they support also what they are calling horizontal scaling, and we have looked at it. You just get a server, add it there, or you just get your physical host, add it there, and boom, you have added more storage on your storage resource pool, on your virtual resource pool. Okay? So this means that it is going to make work a bit easier, because the administrator finds the existing resources. If he finds that they are insufficient, they will just have to get new servers and they add them in the cluster. Or if they find they're giving there many of them, they will just remove one of them without necessarily having to shut down the machine. And then after shutting down, add the hard disk, maybe even reinstall the operating system because it's a new, bigger hard disk, and then you're able to roll it out. Okay, so the administrator can migrate all the virtual machines to certain physical servers in a cluster during the off-peak hours, and then during and then power off and upgrade the other hardware resources. This means also that the administrator can also add servers and storage devices to a cluster without affecting services. That I can choose to migrate these virtual machines. Let's say if they were connecting, if this virtual machine was connecting to this, I can choose to migrate it to this one. Then I shut down this one, because still you're going to access your services, you're going to continue working, add whatever I have to add, even do some maintenance on it, add it back with more resources. Everyone is happy. No service interruption. We are all working. Okay, so the scale up or scale out in virtualization system is easier to implement than the scaling in a non-virtualized system that has less impact on services. Because if you have to scale out or in on a physical device which is not virtualized or in a non-virtualized environment, you have to power off the machine, and then you're able to scale out. So as you're seeing in this animation here, let me clear my drawing. We have our virtual resource pools. We have our different hosts which are connected to our cluster here. This is our cluster. And on our cluster, you see we get all these resources from these machines, some of them. And then our machines are able, like you can see in the animation, our machines are able to use them. Okay, boom. Our machines are using our virtualized features. There they go. So our virtual machine just pick from this pool of resources. If we add another host here, they will just add other resources which our virtual machine will be able to pull from. So if you wanted to add and we decide, like, you know what, let's do some horizontal kind of scaling, and we add there more physical servers, boom. You see, our virtual machines are still having the resources they are using, but also have more resources still available for them to use if they want to, if they have to use the resources. So that is easy scalability, which would be hard to implement during in a non-virtualized environment. So let us look at the fourth feature, which we are calling memory overcommitment. Okay, so we are looking at memory overcommitment, and we are saying memory overcommitment allows us to use more memory than the total physical memory of servers by leveraging on specific technologies to improve on the virtual machine density. Overcommitment technology includes memory ballooning, memory swapping, and memory sharing, and we're going to look at them. So when it comes to, let me click and see if we have an animation. So when you see, we have our hypervisor here, and an hypervisor or your Oracle VirtualBox or our Fusion Compute, we assigned it to 4 GB of RAM. But we can go ahead on this 4 GB of RAM and we create, are you seeing 1, 2, 3 virtual machines? And these virtual machines, each of them, we assign it to 2 GBs. But in actual sense, we are having 4 GBs. So when you add 2 plus 2 plus 2, we get 6. So this way, we are not ideally using the 6, but this way we are overcommitting our memory. And because we have committed 2 here, we have committed 2 there and committed 2 there. And this helps us to run, because this virtual machine, not all the time we will be using the entire 2 GBs. But you may find that some operating system, let's say if you wanted to create an operating system and you have only 4 GB of RAM, and if you configure your virtual machine and you give it 1 GB and you want to install Windows, the setup will tell you, you know what, you do not meet the minimum requirements of a computer of installing Windows. So please increase your memory and try again. But now we're using this feature, it helps us to overcommit the memory that we have so that these virtual machines can benefit and can use these things. So we share our memory, which we are having here. So multiple virtual machines share the memory page on which the data content is the same. You see, if you are running your hypervisor and some of the resources are the same, they're going to be the same like here. Like let's say you have installed Windows here, you have installed Linux here, or you have installed something, Fusion Compute there. And let's say they are using some kind of, this one is using KVM and KVM. So they share this memory. It doesn't have to be replicated. So we are saying with memory sharing, virtual machines share the memory page on which the data content is the same. So if you have a Windows machine there and a Windows machine there and Windows machine there, some of the services are the same. Okay, so as long as the data of that shared page is the same, it will be able to share those and you're able to overcommit your memory. So this is just an example of memory sharing. Okay, so but also you should take note, sometimes it is tricky and they tell you with memory overcommitment, virtual machines can use more than the actual memory. They cannot use, but you can allocate. There's some question that says you can allocate more memory than available. Yes, that is true because that is memory overcommitment. But virtual machines cannot use memory which is not available. We are going to also look at how we can be able to implement to make sure that there is no interruptions of the service and there's no poor performance. We have our quality of services, which are going to look at in the memory and CPU and network quality of services later on in this chapter, to understand how we can configure memory sharing and memory overcommitment so that we have the best performance in our cluster. Okay, so let us also look at memory ballooning. So with memory ballooning here, we see if we have our 3 virtual machines that we created and we assigned 4 GBs. Remember, we are using these things at different intervals, and one virtual machine could be running applications that require to use all the 70, that require to use all the 70%. So if you're having 2 machines, this one is using 70% and this one is also using 70% and this one is using 20%. So the system automatically reclaims unused, all the memory that is unused here. It will automatically reclaim it, and then it will automatically reclaim the unused memory from a virtual machine and allocate it to other virtual machines to use. Applications on the virtual machines are not aware of memory reclamation and allocation. For you, the end user and the application, you're just using memory and you're enjoying. But in actual sense, we are having memory ballooning taking place in the background. Okay, so the total amount of memory used by all virtual machines on a physical server cannot exceed the physical memory of the server, like I've mentioned before. much as we can overcommit, but the total use cannot exceed. So what happens here, these guys are using memory sharing, and this guy will do, what it will do, it to get some of these, as you see, this is unused memory, and then it will get it and it will allocate it here to this guy. You see this same color? We will allocate this memory which is unused on this virtual machine, and it will take it to this virtual machine to use. So that is memory ballooning. Okay, as you see, it migrates and then it goes and it uses it and it shares it across the different virtual machines that need the resources that are not available. And this can be done using the quality of service, and we are going to look at different quotas on how we can actually configure our rules to give priorities to those virtual machines that we want to access or use the memory in case there is competition for the available resources. So let us also look at memory swapping here. Okay. So memory swapping, we see that we can borrow, think of it like borrow. External storage is virtualized into memory for virtual machines to use. If we have our hard disk, we virtualize some portion of it into memory for our virtual machines to use. The data that is not being used temporarily, that is redundant. You open an application, it has been minimized for some good time and it is not being used. So it is pointless for our virtual machines to keep storing them in the memory, which we are competing for. So what they are going to do, they are going to swap that memory and they are going to store it on some kind of external storage. So if the data needs to be reused again, it is exchanged with the data reserved on the memory. Okay, like you're seeing, this guy needs to use the machine, and then what will happen, this guy is having idle memory. So this idle memory is then shared on our like hard disk, some portion of it, like let's say it will get like 4 GBs, and it will store those idle instances on that external storage. And then boom, then also this guy will also do the same. And when it needs to use it again, it will recall it from our external memory. So that is basically memory swapping. We are able to utilize those available features of the cluster features. So we are saying, those who have been attentive, we are looking at memory overcommitment, right? Okay, the answers are there, I shouldn't even ask. And we said it has memory sharing, where we are able to share the memory that is available, and we are able to use some of the shared memory if the data is the same. You see here, this memory is shared, this memory is shared, this memory is shared. So you may find that the 1 GB is shared, and now in total, this is 1 GB that is shared, and this one is using like 512, 256, 256. Okay, so in total, we have actually not exceeded the physical RAM that is available. We also have memory ballooning, and we are saying with memory ballooning, we actually get that idle memory that is not being used, and we reallocate it to the virtual machine that needs to use the resources. With memory swapping, we're able to swap with our external storage, so that we're able to store there our idle instances and then call them back to our live memory when we need to use them. And this is what we are calling memory overcommitment. Okay, so let us also try and look at the virtualization features of our virtual machines. We have been looking at the virtualization features inside our clusters, but now let us also look at the benefits. If you use virtualization, how are we going to benefit from our virtual machines? Here we are focusing at virtual machine. Here we are focusing at the clusters, our group of hosts put together to give resources or to avail resources to the end users. So when we are starting this course, we looked at some of the examples of our public cloud at Amazon. We also looked at some of those of Huawei. We were able to set up some kind of incident, and we had a virtual machine with an operating system which was generated in the background. Like within 2 minutes, we were able to actually create a server online So the time required for installing, if you're going to install an OS all the time, whenever we create a virtual machine and we need to install our OS all the time, sometimes it takes longer. So let us look at some of these features of virtual machine features. And we are saying one of them is what we are calling quick deployment. When we are using virtual machines, we can actually quickly deploy a machine within like 2 minutes, which wouldn't be the case with our manual physical server. If you wanted to set up a machine, you would need to go get all the physical machines that you need. After getting the physical machine, go ahead and buy the operating system, install it, go ahead and pay the licenses, go ahead and buy the software you need, install it, and all that. So we are saying with virtual machines, with using virtual machines, we can actually be able to quickly deploy a computer basing on the need. If you had at your workplace and you have people joining every single time and you're using virtualization, all you need to do is just use some of these features of quickly deploying virtual machines, either by using templates. You use a template to deploy. You have your template, you have saved it somewhere. You all know what the meaning of template is. Or you can clone, okay? You can clone the available machine that is running and you're able to go. It has all your other configuration files and settings embedded in them, and you just change maybe a few settings that you need. So with these features, they help us to quickly and easily deploy machines that are working on the spot. So when you are using a template, usually a template is just a copy. Here, a template is just a copy of a virtual machine. What it does, it contains virtual machine disks. You should take note, a template contains virtual machine disks and also virtual machine configurations. These are some of the things that are contained in a template. So creating a virtual machine using a virtual machine template can greatly reduce the time you need for configuring a new virtual machine and installing an operating system. Once you install your operating system on the first machine you created, and you know you're going to create it for, let's say, 500 employees available in your organization, what you can do, you can just create a template of that one machine, having installed all the applications, Microsoft Windows, Microsoft Office, you have installed your QuickBooks, you have installed your environments, and then you create your template. After creating the template, you can just choose to deploy as many as you want at the same time, and they will come with all those other configuration files and the disks embedded inside them. So this is what we are calling quick deployment. So after this template is created, it cannot be started or modified. So if you create and save it as a template, take note, it cannot be started or it cannot be modified. All you use it for is just to create or deploy other virtual machines. This ensures that the template will not be modified by other users and does not occupy compute resources of the cluster. It is just like it does not, the RAM you assign to it, the memory you assign to it, it is not occupying them. It's just a template ready to deploy a virtual machine from this template. Okay, so virtual machine deployed using template is independent of the template. So if you deploy a virtual machine using a template, take note, the virtual machine is independent of that template. Whatever you do to it, it will not affect our template. Okay. Samuel, not able to. Okay. Vital, there's a possibility there can be vital. Okay. So we have said that if you deploy a virtual machine using a template, it is independent of that template. Okay. So to update or edit a template, you need to first convert it. Take note, please. You need to first convert it into a virtual machine first. So after converting it to a virtual machine, you are able to make changes to that virtual machine, you edit what you want, and then after editing this virtual machine, you convert it back to a template. You convert it back into a template. I hope that is clear. So let us also try and look at virtual machine templates are also useful for deploying large number of similar virtual machines. Yes, please.
Ssendi, I missed you there when you said that should we first how do you edit a template? I missed you there for a second. Thank you.
You have your virtual machine, you have created your virtual machine first. So for you to create a template, you create a template from your virtual machine. You just convert it to the template, isn't it? And we said if you convert it to a template, it cannot be modified or even started. It's just a template, and it doesn't even occupy your resources. It is just like a file on your computer. It doesn't occupy, let's say you assigned it 16 GB RAM. It does not occupy it, it's just a template, and you're going to use it to deploy other virtual machines. And you cannot even modify it. But in case you feel like, that software, the VLC that we put inside this template, we don't like it anymore. We're using another version, and whenever we're deploying, it is deploying with this old version inside it. You have to first convert it back to a virtual machine, uninstall that VLC or the old software that you don't need. After uninstalling and changing or making the configuration, then you can convert it back into our template. Is that clear?
Yes, that is clear. Thank you.
All right. But a virtual machine using a template, you can also quickly deploy a virtual machine using another virtual machine. And this is what we are calling cloning. This function helps you to replicate. It helps you to copy. You have a virtual machine running. All you can do, you can just deploy and copy that. Okay? So you deploy another virtual machine quickly using one which is available and running. It is called cloning. It is different from template-based deployment because the cloning is a process of completely copying the source virtual machine at the specific time in point. How it is, whatever it has inside it, how, like if you have been running it and it's exactly like this at 720, whatever you have cloned will have everything that this virtual machine had by that time of 720. Okay, even the IP address and everything will come. So it gives you an opportunity to have all the settings of each of these cloned virtual machines, including the host name, IP address, and are the same as those of the source virtual machine, like IP address and everything that are says. So as you are cloning it, you need to make sure that you configure some of the things, because if you don't, you get a system report or you get errors that you have two identical IP addresses in a LAN. Therefore, cloned virtual machines and source virtual machine cannot be started at the same time. Why? If you clone the virtual machine, before you change the configuration of the cloned virtual machine, you cannot start them at the same time, because this guy has all the settings that are within this virtual machine. The IP address, the MAC address, like the assigned MAC address and everything will be the same. So if you start both of them, you will conflict on your network and they cannot run at the same time. So what you do, you shut down this one, reconfigure this or change the settings of this one, and then you're able to run them at the same time. So this is what we are calling cloning. Let's also look at another feature for virtual machine.
Samuel.
Yes, please.
With regards to the things that cannot be changed, like a MAC address, how do you go about that?
Excuse me.
You know, MAC address. Yes, please.
And my question is, you've said cloning is like having the same attributes towards another maybe machine. So is it like if I install some application on a machine, is it possible also to install a different application on the other?
Come again. Ask your question again. Just a moment. Please ask your question again.
I'm saying.
Yes, please.
Like with the cloned machines.
Yes, please.
Is it possible for me to do different applications on those machines?
Or as long as like this is, let's say this is our virtual machine running. So if I clone it, everything, even the desktop, it is also somehow a bit similar to us creating our template. But the beauty about the template, like you create the template, assign it whatever you want to assign, maybe an IP range, what those things, because you know you're going to use it for deployment and you cannot run it or even modify it. It's just a template. Okay. Cloning means you're going to get this thing as it is now with my IP address and everything, and you clone it. You just make a copy. Okay. You just make a copy of it and you're good to go. For example, let me see here if I can start up my VMware.
Mic check.
Yes, please. Yes,
I want to contribute. I think what he's asking is, after you've cloned those machines.
Yes, please.
His concern is, say I cloned the machine with VLC, and now I want to install, say, KM player on the cloned machine. Is it possible? And I think the answer is yes.
Yes, very possible.
The cloning just helps you quickly create copies, but after you've created the copies, you can modify the copies that you've created.
Oh, yes, please.
Does that answer your question?
And you're very right.
Yes, right.
Okay.
Okay. So okay, so let us continue. So this is VM deployment, virtual machine deployment using a template, and this is replicating. You're just replicating this, and you can also use the replicated virtual machine and create another one and another one and another one, and so on and so forth. Okay. So that is virtual machine. So let us look at another. Yes, please.
In summary, what is a template in summary?
A template in summary is a template. Okay. Yes, please.
For what I can say is that a template is like
about this template as a copy.
Ssendi, he asked what is a template?
Machine. Let me first explain this. Let me first explain this. You can think about it as a copy of a virtual machine that is stored as a template. You cannot run it and you cannot start it or you cannot modify it, but you can use it to deploy other virtual machines. So think of it as a copy that you are going to use to deploy a copy of these machines that you want to deploy. Okay, so in summary, it is just a copy of a virtual machine, but it does not use the resources. It is just stored on your virtual machine disks, and you can deploy now this machine, which will have the 6 DBs that you allocated in your template. With cloning, it is also like you are copying, copy, paste. Think of it like copy and paste. Okay, you're copying this guy and you're going to clone it. You're going to make a copy, paste that one, copy, paste that one.
Excuse me, Samuel.
Yes, please.
So what you're trying to mean that apart from deploying another virtual machine, a template is useless.
It is not. What do you mean it is useless? Okay.
Like it can't be used for anything else.
Yes, you cannot run it, like you hear a template. Do you know the meaning of the word template?
Yeah.
A template, if you have a template of a website, it is useless. It is not the actual website, isn't it?
It's not the actual website, but you can
I think it is
customize it into being an.
Yes, so you can customize it.
Ssendi.
Then you have your virtual machine. Yes.
Yeah.
Even this template that you're having of a website, you need to first kind of put it in your editor, edit it, then you're able to now turn it into your website by changing that code, isn't it?
Yes.
Yeah, that sounds pretty cool.
Which one?
I've got it.
You've got it? Okay, that's okay.
Yeah.
Someone was saying something. Okay, let us look at another feature, what we are calling resource hot add. When we are using virtualization, it gives us the opportunity, like you saw already in some of the cluster features, you can be able to add resources when the virtual machines are started. So hot add is to add just the computing resources, the storage resources, and the network resources to the virtual machine when the virtual machine is started. So if you have our virtual machine here and it is complaining, you know what, I'm clocking all the way to 75%. My performance is no longer good. What we can do, we can actually get more resources and we deploy, we expand and add there more RAM, we add there memory. Just go and change your settings and add there more memory. Okay, if I went into my VM here and I wanted to, well, this guy is updating now. Okay, if I went into my virtual machine here and I wanted to increase the memory of this virtual machine, okay, I would just come here and then change my settings, and then even when it's on, and then I increase my memory depending on how much memory I want to assign to it. Okay, so as you see here in our slide, this guy is now going to become happy because we have used, or we have logged into our virtual machine and we have increased on our memory. Okay, we have added resources on our virtual machine and now it's at 25% because we have new compute resources, we have new memory resources that are added onto our virtual machine. So from the administrator's perspective, the CPU and memory parameters of a virtual machine are part of the virtual machine configuration file. Like you see, I'm just configuring the hardware configuration of the virtual machine can be modified through modification of these parameters. Just go change the network interface card, change it to whatever you want to change them to. I want it to connect using virtual or NAT. You go there and you're able to change and say, I want it to be hot swappable. I want it to use NAT. I want it to use abridged mode. And when my virtual machine is live, okay, so this means that they can be modified through those modification of those parameters. So when a user is using, like you saw this guy, our virtual machine, and it's about 75% and the user experience is not that good, we can be able to add there, add more features that can be used, like we add more CPU, more memory, and then now our virtual machine is happy. So in addition to the CPU and memory resources, network and storage resources also support hot add. For example, the disk capacity of a VM can be expanded, or a NIC can be added to a virtual machine. Okay. it is easy for us to expand from, let's say, it's easy for us to expand from 512 GB or any GB, like let's say from 8 GB to 16 GBs. It is easy for us to expand, but we cannot reduce in Huawei Fusion Compute and go back and we'll be like, you know what, we now allocated a much bigger disk. Also, if you're using thick provisioning and now we contract it back to 8 GBs, this is not allowed on those platforms, and take note of that. Okay. So hot add functions needs to be supported by the virtual machine and the operating system so that the hot add resources can take effect immediately. Otherwise, if you're using a vendor or a virtual machine that does not support hot add, sometimes you may need to restart the virtual machine, and they can only be identified when the operating system inside that virtual machine realizes that you have added or changed the hardware. So in most cases, resources support hot add but do not support hot delete. Like you can add more resources in most cases, like I showed you can add to 10, 16 GB, but now you cannot wake up and you be like, let me delete that extra GB to make it now 10. So that is not allowed. So usually sometimes it cannot necessarily, more so when it comes to the disk capacity, it cannot necessarily come to that. So another feature is that with virtual machine, this was resource hot add. Then we have another feature of where we have an opportunity to use a console to log into our virtual machines. Okay, and here virtual machines can be operated using monitors. But physical machines, I mean, they can be operated using monitors. When you're on your physical machine, you have the monitors. But with the case of virtual machines, you need some kind of console for you to be able to monitor and utilize your virtual machine. Okay. So once the network is disconnected, virtual machines may be controllable. So even if when we disconnect the network, if you're using a cable, you can just tap into that host that is having your memory, your virtual machine, then you're able to control it. So a real-time virtual machine control technology is required. So most hardware devices that cannot be controlled to display the system are configurable within an independent management interface for the users to perform management operations. For example, in addition to service interface, storage devices are configured with control interfaces, and these network devices are configured with console interfaces. So also VMs can be controlled in the same way. You have some kind of console and you access your virtual machine. Yes, please. Yes, please.
Do the consoles need to be on the host machine?
Do the consoles do what?
Must the consoles be on the host machine?
Does it mean that what?
Does it mean that the console to control that particular virtual machine should it be on the physical machine?
Yes, on some kind of platform where you need it. Like usually sometimes this is a console, okay? Are you seeing my terminal? Sometimes they call it terminal, sometimes they call it a console. So you need some kind of console for you to be able, and you can log in, okay, using that console that is provided. So that's why each vendor provides a console management function for their virtual machines, where you can go and either use it remote, use remote console that is used by VMware. Huawei uses Huawei and KVM use a terminal called VNC. Take note of that. Uses a terminal called VNC. The console is network dependent. You must be on the network for you to be able to connect on the VNC that is supported by Huawei and KVM. Okay, and we are saying for this console, it is network dependent. It depends on the network. So if you need to log into this VM from not need, yes, please. I think So we are saying if you need to log into the VM, if you need to log into this VM or this VM using a console, you do not need to configure an IP address for the VM, but you must configure an IP address for the compute node where the console is located. So if you know that your Fusion Compute is stored on a host which has an IP address of 192.168.5.234, you just need to know this and you use it, but you don't have to configure an IP address for your virtual machines for you to be able to use the console, let's say for Huawei, which is VNC. Okay, so I repeat this statement. One, it is network dependent. Two, if you want to log into that console, you don't need to configure an IP address for the virtual machine. All you need is to know the IP address of the host where that virtual machine is stored. Okay, all the IP address to your cluster, and then you are good to go. Okay, so the compute node functions as the server to provide services for the users to log into the virtual machine. Therefore, you need some kind of compute node. So the network between the client and the server must be normal. So you must have some kind of connection. That's why we are saying here with these consoles in Huawei, that network dependence. You need to have some kind of connection to that server where our virtual machines or where our Fusion Compute is stored. Okay, so that is the feature we are calling console control. Let us also look at another one which are calling a snapshot, and I want you to pay maximum attention to this. We are almost running out of time, but I intend to finish this topic for today, which we are going to finish by God's grace. Yes, there are a few slides left. So we are looking at third feature, which we are calling snapshot. If someone can remind me, what are the other two features that we have looked at before for the virtual machines? For virtual machines?
Yes, resource hot hard.
Resource hard add. Yes, and
quick deployment, console control.
Quick deployment.
And
yeah, quick deployment.
Quick deployment.
Quick deployment.
Yeah.
And console control, right? So we're now looking at a feature called snapshot. So we are seeing in virtualization, snapshots are similar.
Virtual machine.
Yes, please. In virtual machine features, yes. So we are seeing that this is also similar, the snapshot. Who knows how to take a screenshot? Many of you have been taking your screenshots and I'm able to see the state of your performance, isn't it? Or the state of the errors you're getting from the server. So we're also saying this is also similar on the way we take our screenshots in our normal life, or the way even we take pictures. So basically what a snapshot does, it records the status. It records the status of a certain moment and certain content. A certain moment, and it contains complete data of the virtual machine. Okay, so what it does, it takes like a snapshot or like a record of the VM status at that particular time, and it also contains complete data. It also contains complete data for the virtual machines. So you can use also snapshots to restore a virtual machine to the state at a specific time when that snapshot was created. Okay, so generally a snapshot, they are used to quickly restore a virtual machine if maybe a virtual machine is faulty, maybe before an upgrade we had to make some patching, or maybe we want to test something we take a snapshot before and after we are done doing all those funny things on our virtual machine and the things are not working out, then we can choose to use a snapshot, which is a fully usable image to define collection of data and contents of an image of the data as it is appeared at a given point. We are able to restore it either a copy or a replication of a specific data. Okay, so snapshot technology, we usually have the following functions because we can easily use it to quickly generate and use data resources for traditional backup and archiving and reducing or eliminating backup windows. So you can just take up a snapshot of a given virtual machine or a given machine at that given time, and then we are able to store it. So thereby reducing the functions of the backup. So when we are looking here, we have our original. Let me go back a bit. We have our original virtual machine here, and we are reading and writing from it. So we take a snapshot of it. When you take a snapshot of it, at that time when we took a snapshot of it, it will be like that. Okay, and we can use this snapshot to now restore this original virtual machine to how it was before. We can use it to deploy a virtual machine and it is exactly like the way it was at that given time. That is just a snapshot. Okay, so we can even take a snapshot of a snapshot. Okay, and then this snapshot will also have that virtual machine that is created. Okay, and we see the user also has the functionality to read and write from the new snapshot that was taken at this given time. This was snapshot 1. So we also continue to take another snapshot maybe after 2 days when we have more things that are added on. Okay, so basically those are just snapshots. So when we decide to create our virtual machine using snapshots, our virtual machines will also be looking similarly to that. They will be exactly like how the snapshots were taken at that given time. So that is snapshot 1 and that is snapshot 2. So when you go ahead and delete one snapshot, you see that this guy moves and becomes now snapshot 2, and then we are able to read and we are able to delete, and this is our final product. So we are saying snapshots can quickly generate, can be quickly generated using can be quickly generated and used as data sources for traditional backup. We also say that snapshots are stored on disks and they can be quickly accessed, accelerating data restoration. You just store them on your disk and you access it when you want to restore your disk. So based on disk-based snapshots provide flexible and frequent restoration points for storage devices. In terms of specific technical details, a snapshot creates a pointer list that indicates an address for reading and writing data. So when data changes, that pointer list can provide real-time data in a very short time and perform a replication. Okay, so common snapshot modes are copy on write, what we are calling the cow, copy and write, copy and write, copy on write, sorry, copy on write, which we are calling cow, and then also read on write, which we are calling row. Okay, so both these two of copy on write and read on write are concepts in the storage domain. Most vendors use the row, most of them use row technology to create virtual machine snapshots. So no matter whether we have used the copy on write or read on write, still physical copy operations will not be performed and only the mapping is modified. So this we shall now go ahead and okay, we shall now go ahead and look at another feature called NUMA. Okay. So we have so far looked at snapshots. We went ahead and looked at memory hot add. We went ahead and looked at quick deployment, either by template or by cloning. Here we have hot add and also console control. We have snapshots. And now let's look at some technology called NUMA, what we are calling the non-uniform memory access, which we are saying it is a technology that can improve data read and write speeds. Here we are using it to improve read and write. You forgive my handwriting, which will improve the read and write speed of data. So today, in these modern times, computing speed of a single CPU has reached the bottleneck. So most designers adapt what they're calling multi-core CPUs to improve the computing speed for computers. The CPU and memory are connected through what they are calling the North Bridge. As a number of CPUs increase, then that means that memory increases also accordingly. So as a result, the response speed on the North Bridge becomes slower and slower because it has to connect. The North Bridge has to connect those guys. So then the North Bridge makes it hard and it becomes slower and slower. So therefore, designers evenly bind the memory of each CPU to avoid congestion caused by North Bridge sharing. Okay, so we have our NUMA here. So what they do, they somehow connect directly without us having need to connect the memory.
Mic check.
Yes, please.
I had a network glitch. Please pardon me. What's NUMA in full?
NUMA, we are calling it the non-uniformed memory access, which are saying it is a technology that we use to improve the data read and write speed. And we are saying it came in place because now today we are using massive compute resources, and the way originally how they built our computers to communicate, our CPU communicates or connects to our memory using the North Bridge. So they came up with this technology so that we can be able to bind our memory to each CPU. We're able to bind our memory to each CPU, and so that we are able to utilize and use NUMA. So as you see in the diagram here, as you see in the diagram here, we have our CPUs and memory. So what we do, we're going to have our virtual machines, and we're going to get this memory which is connected to that CPU, and we take them together. Also this memory that is connected to that CPU, and we take them together. Okay, so that means I is also going to be able, you see now with this one we are getting memory from different nodes. Are you seeing the animation? Please look at the animation clearly. So after the modification or memories associated with CPUs, we can have a CPU, and a CPU can access its own memory faster than the normal or the non-local memory. As the local access speed is high, it is more efficient for programs to use a CPU, and it is associated local memory. This technology is what we are calling NUMA. So what you should take note, and you should not even focus so much on understanding the underlying technology. What you should understand that NUMA is a technology that is going to help us eliminate the bottlenecks of the North Bridge so that we can increase on our read and write speeds of our data. Okay, so NUMA nodes are CPU and memory couples. So each node has a CPU bus and memory. So cross access requires NUMA interconnection between the CPUs. In virtualization scenarios, NUMA enables to use hardware resources on the same NUMA mode, improving the virtual machine response speed. Okay, so what NUMA helps us to do, it increases on our read and write speeds, and then also it enables us to use hardware resources of, are we together? Hardware resources of the same NUMA mode, and then therefore we can be able to improve on the response speeds. So let us go ahead and look at the introduction to the features of Huawei virtualization products. So what are the prerequisites for enabling advanced features? Okay, if you want to enable these tools that we have been talking about, we've been talking about live migration, we've been talking about taking snapshots, maybe you're changing the flavor, modifying our VMs. We have talked about quality of service. We're going to look at it. So how can we be able to do all these things if we are using a kernel mode hardware drivers or using a user virtual machine agent process? We can be able to do some of these things. So if you need to see the virtual machine information, you use the user mode in our virtual machine agent. And if you need to use, you want to view hardware information, you use the kernel mode. Okay.
I check.
So yes, please.
Mr. Ssendi, and just apologies. I will be ending here because I have to go and catch coffee today. I did not have data, so I did not attend from home. So I have to leave office, but I will surely follow the video tomorrow and catch up.
All right, please make sure you do so.
Thank you.
Okay, so we are saying here that in Huawei Fusion Compute, as if you want to use or to access the different resources on a computer using our virtualized environments, we are going to use the kernel mode if you want to see the hardware drivers. And if you want to see the processes, you use the information status. We use our user mode for the VM agent process. So what you should take note is that in Huawei Fusion Compute, we only support the cluster and virtual machine features we have mentioned before. Who can tell me the cluster features we talked about before, briefly, because you're running out of time?
What?
Load balancing.
Load balancing.
High availability.
Yes.
Scalability.
Memory overcommitment.
Memory sharing.
Okay. And so on and?
Memory swapping.
Okay.
Those are under memory.
So we are saying that Huawei Fusion Computing supports all those features, but it also goes ahead and it provides some enhancements for general virtualization features. So to use these features supported by Huawei Fusion Compute, we need to install some tools on our virtual machines. Okay, and this is the tools that we need. We are talking about the kernel mode tool to enable us take live snapshots, live migration, online VM change, and the NIC course. And also we need to install the user mode VM agent process to help us do that in Fusion Compute. So the kernel mode hardware driver allows administrators to perform virtual machine operations such as snap creation, live migration, online VM flavor adjustment or change, and the NIC quality of service settings. While this user mode agent process allows us to be able to obtain the virtual machine MAC address, the virtual machine status, shutdown a given, soft shutdown of a given virtual machine, and also to restart our virtual machine. So tools installation methods vary depending on the operating system. Sometimes you just need to follow the guide and see how we can install tools, how we can uninstall them, and so on and so forth. So let us also try to look at the different clusters in our Huawei virtualized product. Okay, we see we have already looked at high availability. Who tells me what does the high availability do? Are we there?
High availability ensures that
come again.
In case of high availability ensures that in case of failure of one host machine,
okay,
the services of other virtual machines are supported by the
okay, so high availability, yes. So we are saying in Huawei Fusion Compute, we support both memory overcommitment and also the NUMA technology. What does NUMA do?
NUMA increases it increases the read and write data.
NUMA improves the read and write
speed of data.
Awesome. So let us look at high availability. We have already looked at it, and we say that in case one host becomes faulty, we can migrate our virtual machines to another functioning virtual machine and we are good to go. So similarly, in Fusion Compute, clusters support multiple high availability policies, and sometimes users can configure these high availability policies based on the following. One, you should take note, if there is a host failure, okay? So if there's a host failure and you can configure the host fault policy, okay? So if they ask you, under what circumstances can you configure a host fault policy? We consider this in case there is a VM, there's a host or a CNA host failure. It is straightforward. So usually to restore virtual machines on a regular host, so when the host accommodating the virtual machine is faulty, the system restarts the virtual machines only after the host is restored. That's when the system is able to take it back and then it resets that virtual machine. So that is what usually happens. So when you put there the high availability policy, so when that host becomes faulty, the system restarts the virtual machines from another host based on the virtual machine startup policy configured in the cluster. So we are also looking at what we are calling the data store failure. Our data store is something we connect to our storage resource pool. So usually what happens if we have we've configured data store fault handling policy by the host, you're advised to select no action, okay? You're advised to select no action in that policy. So if the parameter is set to no action and the data store fault exceeds the value of the policy delay, the VM receives an input and out error. Remember our heartbeat mechanism, which is sent every after 30 seconds. So it receives an input and output error, causing the OS to become abnormal. Alternatively, you can select high availability. So these are some of the policies you can configure. So you can configure high availability in case there's a data store fault policy, in case also the host is policy. So if the data store fault duration exceeds the value of the policy delay, the system starts the virtual machines from another host based on the virtual machine startup policy configured for the cluster. So what is this delay that we are talking about? They're usually minutes, and for handling policy upon data faults to take effect. So within that given duration, the backend driver sends the input and output requests. So you're advised to set the policy to a larger value that does not exceed 14400. So if you're configuring your delay policy, you make sure you set it to a value that does not exceed 14,400. Okay. So also we can configure high availability in case there is a virtual machine fault. Okay, so usually some action we can say no action. And then also sometimes if there's a virtual machine fault, we can restart the virtual machine, or we can choose to configure high availability policy so that it can restart from another host. So what we are saying here with high availability, we are basically saying that in case the host fails, we can choose to put in an option of saying that we should transfer our virtual machine. Excuse me. Hello. Yes, please. Good evening. Yes, Ismail. Yeah, that is okay. That is okay. Kindly just send me an email. All right. Are we together? So you can either choose no action or you can choose to turn on high availability. Okay. So the same case with when there's a data store policy, you can choose no action. Okay. Data store policy, you can choose no action policy so that the system handles it. It uses the handling a policy by the host, or you can choose the policy delay, or you can use high availability. So with the data store, we have two of them. There's a fault handling by hosts. Fault handling by hosts. Then we also have the policy delay. Then we also have high availability. We can configure those in cases of data store policy. Okay. So also in times of blue screens of death, usually they happen only on the Windows virtual machine. So if there's a there's a blue screen of death, usually the handling policy is supported by virtual machine faults. So if there's a virtual machine fault and you receive a blue screen of death, you can also go ahead, and sometimes it creates what they call a high availability policy for you. So that is high availability, and load balancing, we looked at it. We also are going to look at IMC, and let's now look at what we are calling the distributed power management. So we have another feature here. I don't know if they're talking about it here. Okay, yes. So we have another feature which they're calling high availability. We have looked at it. Sorry, not another feature. We have looked at the high availability. We are saying we can either choose to restore it or restore it on the original hosts. Okay. In case it fails, restore it to the original host, to the original host, or we can configure a higher availability mechanism, or we can even do nothing, or we can, in case of a data store, we can configure high availability or do nothing. In case it is the physical host, we can configure VM high availability, or we can restore it on the original host. Okay. In case the virtual machine is the one which is faulty, we can do nothing, restart the virtual machine, or configure high availability. Please take note of that. In case the virtual machine is faulty, we can do nothing, restart the virtual machine, or configure the high availability policy. What time is it? Okay. So let us go ahead and also look at the power.
Now, when you do nothing, what happens?
When you do nothing,
what happens?
It may depend on the scenario why you are doing nothing. It could be maybe, let's say the data store, maybe you were connecting to your Fusion storage and maybe it was some kind of connection, and it does not necessarily need you to configure high availability policy. Okay, so let us say this guy is faulty and you want to figure out, sometimes you may need to figure out and troubleshoot as a system administrator what caused this virtual machine to become faulty on this. So not all the time that it automatically takes you to high availability. It depends on how you configure it. Maybe it's in debugging mode and you want to know what exactly happened. So it does not restart the virtual machine on another host, so you're able to see and troubleshoot and debug the virtual machine to see the fault, or to see the cause of, maybe let's say if it's a Windows virtual machine, the blue screen of death, because you need to establish why. Is it the configuration file or something like that? So it entirely depends. But those are the options that are available for you in Huawei Fusion Compute. You can either choose to do nothing, you can choose restart, or configure the high availability option. So let us look at the distributed power management feature. Distributed power management feature. And basically this is just to help, like you hear distributed power management feature. What happens is that during off-peak hours and you're not using all the resources, what happens is that it will get some of your virtual machines. Let me play the animation, it will help me explain it better. It will get, let's say like it gets to like 11:30 at night, and most people have gone home and most of the resources on the server are idle, but the server is turned on and it's consuming a lot of your money. So in Huawei Fusion Compute, we have that feature called the distributed power management, which enables the system to periodically check resources usage on a host in a cluster. So if the resources in a cluster are sufficient, but the service load on each host is light, then the system migrates some of the VMs to other hosts and then powers off these hosts, reduce on the power consumption. So if the services are now overloaded, the system will power back the hosts that were off, and then it will do load balancing among the hosts. So it is basically an automated power management function, and it is enabled by the system administrator, or sometimes it can be automatic. And also it must be enabled so the system automatically balances virtual machine load on the host after host power, or after the other servers are powered on. So like you see in this animation here, we are seeing that after 12:30, like most people have gone home and there's lightweight on these virtual machines. They're not using them. So for us to be able to save power, and we don't run most of them, it will shut down and power off these hosts because we configured the policy on them. And then after some time, like at 7 in the morning, and everyone comes back at work and everyone is trying to access things, then it will go ahead and it automatically powers them back on, and then we do load balancing on them. Okay, we are able to do load balancing on them. So the time-based power management setting allows the system to manage power in different time periods based on the service requirements. When services are running stably, or set automated power management on a low level to prevent adverse impact on the services. Okay, so it is just basically that with distributed power management, basically to help us save the power and shut off some hosts as needed, then power them back on during the time that we configured our cluster to power on using our distributed power management feature. So let us also look at what we are calling the distributed resource scheduling. What time is it? Distributed resource scheduling. Okay. Our DRS, distributed resource scheduling. And we are saying with this, basically it is to help us, and sometimes the distributed resource scheduling and distributed power management part of load balancing. Usually we combine these two, okay? A part of load balancing. So distributed resource scheduling provides a reference for system migration during load balancing. As this guy is doing his distributed power management, it also uses a technology of DRS to distribute the different virtual machines while doing load balancing inside that cluster. So we are saying we have some of these, come again? Is someone calling me? Okay, so we are saying we can use the keep virtual machines together, and please take note of this. When you use the keep virtual machines together, this rule keeps the selected virtual machine. If you say this virtual machine and this virtual machine, whenever you're transmitting, let's say this is your database server, and this is your application server, and you need this guy to connect to this guy. They must be always together. You configure a rule and you say whenever we're doing our distributed resource scheduling and our distributed power management to achieve load balancing and high availability, keep these virtual machines always together. So it keeps the selected virtual machines that are always running on the same, they always run on the same host. Even when they migrate, they will migrate together to that host. Okay? This guy will go, the moment he goes, this guy is also goes and follows him. Virtual machine 2 will go and follow him. So we also have another feature which we are calling keep virtual machines apart. In case maybe this is a backup, this is our database, and this is our database backup. We don't want them to be on the same host in case this guy just dies. So we want them to always be on different hosts at different times. Maybe we even don't want them to conflict. Okay, so what we do, we configure always to keep them apart. So when you configure that rule, and whenever they migrate, and this, okay, if this guy migrates, are still illustrating this, this guy will also come and follow him. So this animation, if this guy migrates to our host A, because we know we configured this distributed resource scheduling rule, that whenever these guys must keep apart, this virtual machine 2 will definitely migrate and run away and go to another host. So when also this one migrates and comes there, automatically this one will come, like we studied in science, that the poles of the north poles, and if they are of the same nature, they repel each other. Okay, so that is the keep apart or keep virtual machines apart. So we also see another one of virtual machines to hosts. Okay, so this rule associates a virtual machine group with a host group so that a virtual machine in the specific virtual machine group can be configured to run only the specific hosts in that group. In case you have some hosts and they have, let's say like this one has SSD, and you only want your applications that need fast read and write speeds to be only in that group of clusters of hosts. So you configure that rule, virtual machine to host, you bind them to a host or to a group of hosts. So that these ones which are having normal hard disk like the HDD, they will not migrate and they will not go to them. Okay, so that is our distributed resource scheduling. Now let's also look at an important feature in our Fusion Compute. And we are saying on Fusion Compute, enabling incompatible migration cluster, the IMC mode for the cluster allows virtual machine hosts that are using CPUs with different performance baselines within the cluster. What IMC helps us, because sometimes you have different hosts with different CPU generations and make. So what this thing helps us, it allows the virtual machines to migrate between hosts that are using CPUs with different performance baselines. Okay, so within that given cluster. So currently IMC mode only allows live migration between hosts using Intel. Please take note of that. It only allows live migration between hosts using Intel CPUs. IMC mode allows hosts in a cluster to present the same CPU function set to VMs running on them. It allows us to present the same CPU function set to VMs running on them, despite the fact that these hosts may be using different CPUs with different performance baselines. So for the IMC mode to work for a cluster that already contains hosts and virtual machines, ensure that the following conditions are met, and take note. The CPU generation of hosts in the cluster must be the same or later than the target IMC mode. So if you're using CPU of the 3rd generation, it must be either 3rd generation or 4th or later on, but not 2nd generation. Okay, so take note of that. CPU generation of hosts in the cluster are either the same or later than the target IMC mode. Then we can be able to enable our IMC mode on that given cluster. So also if the CPU generation of the running or hibernating virtual machines in the cluster are the same as or earlier than the target IMC mode. So what you should take note, the CPU generations of the hosts must be the same or later. The CPU generations of either the virtual machine running or maybe you have hibernated it, okay, they must be the same or earlier than the target IMC mode. So for the virtual machine, same or earlier. For hosts, same or later. That's a difference. So if any virtual machine in a cluster does not meet the requirement, stop the to stop this virtual machine or migrate. This will stop the virtual machine to migrate, or we can actually either stop it or migrate it to another cluster because it will not work under this IMC mode. So basically what we're taking from this is the IMC mode enables us or helps us to be able to, like you hear the word, incompatible migration cluster, to help our virtual machines migrate from one cluster or from one host to another. But remember, they have different CPU performances and speeds and baselines. So, and it also works only in Intel CPUs, and it can only work when these conditions are met. Okay? If we are the CPU generations of the host in the same cluster must be the same or later than the target mode. For the virtual machines, it has to be the same or earlier than the target IMC mode. If that is the case, you must either stop the virtual machine or migrate it to a cluster that meets the requirements. So let us look at our, am I going back? Our virtual machine features. It's already 9. Okay, we're going to cover this briefly. We have been talking about the quality of service. Bear with me, we're about to finish the class for today. We've been talking about the quality of service, and we see we have resource management, where we're going to manage our resource costs, memory costs, disk scaling, adding or deleting network interface cards. These are some of the virtual machine features we have already looked at. Okay, already we have fast deployment, and we discussed this already. Our VNC login, which we said we don't necessarily need to configure an IP, but as long as we know the IP of the host. So let us look at CPU and memory cores quality of service. So the CPU quality of service ensures optimal allocation of resources of virtual machines, and it prevents resource contention between virtual machines due to different resource, due to different service requirements. So in case there is some kind of competition for the resources, this helps us to utilize the resources, because we are going to either reserve, we are going to pass a quota, we are either going to limit our CPU based on the priority of our machine. So during the creation of virtual machines, the CPU cost is specified based on the service to be deployed. The CPU cost determines the computing capabilities of a given virtual machine. Okay, so the system ensures that the CPU cost of virtual machines by ensuring minimum computing resources and resource allocation. Let me repeat again. The system ensures the CPU quality of service virtual machines by ensuring the minimum compute resources and resource allocation priority. What you should take note of, by ensuring minimum, take note of that word, minimum resources, minimum compute resources and resource allocation priority. We are looking at resource allocation priority and minimum compute resources. Okay, so CPU cost is determined by the following aspects. We look at quota. Quota basically designed, like you hear quota, it defines the portion based on which CPU resources must be allocated to each virtual machine when multiple virtual machines compete. And I repeat, when multiple virtual machines compete for the same physical CPU resources. So if we have, don't worry, we are done. The next slide we are finishing. So if you have our three virtual machines, virtual machine A, virtual machine B, and virtual machine C, and they are all running on the host and they are using a single core physical CPU of 2.8 gigahertz. Okay, and their quotas are set from, let's say, we have a third of 1 to 2 to 4. By that I mean 1,000 to 2,000 to 4,000 respectively. So when the CPU here we have 1 to 2 to 4. So when the CPU workloads of the virtual machines are heavy and the system allocates CPU resources to virtual machine based on those quotas we have defined, virtual machine A with the 1,000 CPU quota can obtain a computing capability, because when you do the ratio of 1 to 1 to 1 to the 2,800 gigabits we have, 2.8. So that means this guy will now have a quota of about 400. This guy here will have a quota of about 400, isn't it, megahertz? While B will have another quota of 2,000. Okay, and then now our virtual machine B, when it obtains that quota of 2,000, it can now obtain the computing capability if virtual machine C now comes online and it is using all its quota. Initially, if it has obtained this, okay, and virtual machine was using this, but if you're using the quota, this now needs to use all its 4,000. Okay, that means that if we are to use this guy will now have to reduce and it will go back to the 400 that it is supposed to use. And then now the computing capability will now drop all the way, because now if virtual machine B, which we have configured with 2 here, if it is using our quota of 2 and we have calculated this, let's say it is 2,000 and this guy is using all that, that means if it is using the entire 2,000, these guys will now use 400 each and 400. Actually, this guy will now use half of the remaining, which is 600, okay? And then now this guy will use the 200. So the CPU quota takes effect only when resource computation occur. As long as there's competition, then that's when we shall have CPU quota. But as long as it's not there and they are performing below their quotas, they're able to use as they can. But in case there is resource competition, that's when we apply CPU quota. So let us also look at CPU reservation. Okay, this reserved or reservation. So reservation defines the minimum, and I repeat, it defines the minimum CPU resources. It defines as minimum CPU resources to be allocated to each virtual machine. Okay, so when multiple virtual machines compete for physical resources, this will define that, you know what, this virtual machine A should never exceed this one. Okay, we looked at quota. For it just defines the portion based on which CPU resources to be allocated to each virtual machine when multiple virtual machines. So basically this one just decides the portion. Reserved, for it defines the minimum CPU resources to be allocated, just like you hear the word reserved. Okay, then let's look at limit. So with limit, like you hear, you're limiting something from something. So with CPU limit, it defines the upper limit. For it defines the upper limit, all what you can think of as the maximum. Reserved, we are looking at the minimum resources that can be allocated to a given machine. With limit, we are looking at the upper limit of physical CPUs that can be used by a virtual machine. For example, if a virtual machine with 2 virtual CPUs has an upper limit of 3 gigahertz, each virtual CPU of the virtual machine can obtain at least 1.5 compute resources. So let us also now look at memory quality of service. And we are saying with memory quality of service, it basically, this allows virtual machine memory to be intelligently reused based on the present percentage of the reserved memory. So intelligent reused based on the preset percentage of the reserved memory. So memory overcommitment technologies such as memory ballooning are used to provide more virtual resources for virtual machines. But this function maximizes memory resource reuse. So when we're looking at memory quality of service, we are focusing so much on memory reuse. That is one. Also, we are looking at how best can we utilize our memory. So we're also looking at memory utilization and also ensure that virtual machines can obtain the reserved memory at least, and also guarantee reliable service operating scenarios. So system administrators can set the memory percentage based on the service requirements. The main principle of memory overcommitment is to first use the physical memory. So if we don't have enough physical memory, then we can think of memory. We can think of using memory quality of service and memory overcommitment. So like CPU quality of service, also memory quality of service has these 3: quota, reserved, and limit. And we have already looked at them. Quota deals with the portion based on which memory resources to be allocated to each virtual machine when multiple virtual machines compete for the resource allocation. Okay, so the same, you do the ratio. Then also memory reservation also looks at the minimum memory resources, like we talked about, minimum memory resources that can be minimum memory resources that can be allocated to each virtual machine when virtual machines compete for the same resources. And we also looked at the, maybe we can take note that virtual machine executors will use reserved memory. Usually they use this reserved memory. Okay, so if certain memory resources are reserved for a virtual machine, other virtual machines cannot use the memory resources, even if the resources are idle. That's why when you notice, when you create a virtual machine and you assign it 2 GB, that 2 GB will be taken away from your host, and it is usually because they are using the minimum, or what we are calling the reserved quality, part of memory quality of service. So then we also have memory limit, and with memory limit, we have this also specifies the maximum, or what we call the upper limit, the maximum physical memory resources that can be used by a given virtual machine. Okay, so that brings us to network quality of service. Let me also talk about it. It's not wide. So with network quality of service, basically it is a policy that controls the bandwidth configuration, and it is also determined by these following notes. The bandwidth control based on sending or receiving direction of port group members. So we are looking at the sending direction, sending and receiving direction. So when it comes to network quality of service, we are looking at the sending and receiving direction of the port group members. Also, we are looking at traffic shaping and bandwidth priority configured for each member port in a group. So we're looking at bandwidth control, and this one we said it bases on the sending and receiving direction. And we're also looking at traffic shaping in network quality of service. So that brings us to the end of this chapter. For those that are still on the call, let me see. Okay, not so bad. People have stayed around. That brings us to the call, and we see that we have which of the following is not a snapshot management option? Which of the following is not a snapshot management option? We talked about them. Can someone say something? What you understand?
B. Replicating the snapshot.
Come again?
B. Replicating the snapshot. There's option B.
The answer is B.
B for dog, B for boy, D for dog.
B for boy.
B for dog. B.
One is saying B, one is saying D. Which one is which?
Me, I'm saying B. Modify a snapshot.
Okay. Modify a snapshot. We already looked at this and we emphasized and stressed the point. We said they cannot be modified. If you want to modify a snapshot, you first convert it back to a virtual machine, isn't it? Make your modifications after modifying. That was a template.
Yeah, the same stuff.
Okay. Templates can be used to quickly deploy virtual machines. At the present, templates can be created only by converting or cloning virtual machines.
Is it true?
That is true. Okay. So let us, before you go off the call, you have an assignment here. It is not huge. And usually this is what we do. You are going to use tomorrow's class to go through chapter 6 and discuss it. Okay. Who can lead tomorrow's discussion with cloud computing trends? Cyrus Sumika. Okay. So Cyrus Sumika is going to lead tomorrow's discussion, and attendance is key. I'll be part of the call. But the assignment is you go and read about the trends. This is the easiest chapter about cloud computing trends. They're just talking about Internet of Things, talking about big data. Okay, they're about big data and also characteristics of big data and all that. And usually we use this class to have our class engagements and have people discuss. Okay, so there are just 40 slides with minus about 6 of them. Actually, we have like about 32 slides available. Okay, so in tomorrow's class, you will be discussing